can't see it. It's
9:38.
So sit down.
It's 8:38. Don't you need those to see? Don't calm down.
All right. Everybody should be facing front, ready to take your notes, please. All right. This is, every time I turn on the recording, I can't talk. All right. This is going to be some vocabulary. I don't want to write with a red pen.
Well, you already
From chapter 14, section 2 and 3, that I went back and needed to pick up some stuff in section 2 and then finish off some stuff in section 3. First word is mono, so monoprotic. What does the prefix mono mean? A. Bronsted, Lowry, acid, that can donate only 1 proton per molecule. Example, HClO4, HCl, and HNO3. If you look up here, you see that there's only one H for each of these acids. And there's more than these, but these are just some examples. We'll use one in a reaction. HCl, gas, plus H2O liquid, goes to H3O plus, plus Cl minus. It is only able to donate 1 hydrogen, okay, 1 H plus. The Cl minus has no other hydrogen to lose. So HCl has only one ionization step. Okay. Next vocabulary word is polyprotic. Polyprotic. What does poly mean? 2 or more. Right. More than one. Yes, honey. A Bronsted, Lowry, acid that can donate, more than one proton. If you missed the word proton not knowing that's H plus, shame on you. How many times have you written it? Mm-hmm. Example. H2SO4. See how there's more than one H? H3PO4. There's 3 H's there. Okay. Diproduct. Acid. For some reason, this is bugging me. Does that look as clear as it usually does? Huh?
Because it's foggy.
16 to 1200?
My gosh.
Does that look better?
It always looks like that.
Huh? Yes or no?
Yeah.
Yeah, a little bit.
Yes. I'll make the video huge, but. Oh, my bad.
Oh no.
It's Studley.
It's
Oh.
Studley. Okay, blooper. Blooper.
Is this recording?
Malfunction. Okay.
Miss Dudley got a little too late.
Blooper.
I don't have it.
I was just gonna fix something.
Hold on.
Explain what happened to every other class.
I was impersonating Miss Hash Brown's laugh.
Do it again.
The hash slinging.
Hash brown.
The hash blinging. Slashing. I knew this guy. Who knew this guy? Who knew this guy? Who knew this guy? Who knew this guy's cousin? That's like one of the best episodes of
Cocaine? Yes? Cocaine?
Ready, gosh. Ready, gosh. Make sure everybody will know who it was. Okay. Sorry for the interruptions. I told you my first period gets weird sometimes yesterday. Alright. Diprotic acid. A polyprotic acid.
Remember Polly Pocket?
I do actually.
And there's a video game.
Oh my goodness.
Polly Pocket, she stuck up her nose.
A polyprotic acid that can donate.
I love Strawberry Shortcake.
Shh.
And all the Strawberry Shortcake.
That can donate 2 protons. Per molecule. What does the prefix di mean? 2. Hence why they can donate how many hydrogens? 2. Alright, example. H2SO4 liquid plus H2O liquid, H3O plus aqueous plus HSO4 minus. Okay. The hydrogen sulfate ion is a weak acid. Why is that? Why is HSO4 minus
Is it lost?
Well, definition of weak. It establishes the following equilibrium. Is equilibrium 1L or 2Ls? 1L? In solution.
Got it wrong last time.
Well, 1 or 2. Okay. Do you see only the single arrow? Okay. The first ionization will not go back and recombine. All right. Now, HSO4 minus plus H2O, double arrow. H3O plus SO4 2 minus. All right. They ionize in steps. You had 2 hydrogens up here in H2SO4. This reaction shows you losing only 1 hydrogen, leaving HSO4, hydrogen sulfate. Now, the HSO4 minus sets up a equilibrium with a double arrow, which is telling you it can go back and forth, okay, and producing the H3O plus and the SO4 2 minus. All stages of ionization of a polyprotic acid occur in the same solution. Sulfuric acid therefore contains H3O plus, HSO4 minus, and SO4 negative 2 ions, all in the acid, sulfuric acid. Okay? H3O plus, HSO4, and SO4 2 minus. Okay? Triprotic acid. What does the prefix tri mean? So how many ionization reactions will you see if it has 3? 3. An acid able to donate three protons per molecule. Okay, we start off with H3PO4 plus H2O. Double arrow. Why? Is H3PO4 a strong acid? If you can't answer that question, you haven't done what I've asked you to do. It's not. It's a weak acid, therefore the double arrows. Okay, there's the first one. Now you take the remaining ion here, H2PO4 minus plus H2O, double arrow, H3O plus now what? What's the charge? -2. And the last ionization step, starting off with this, HPO4 -2 plus H2O, H3O plus what? That's right. A solution of phosphoric acid contains H3O plus, H3PO4, H2PO4 -1, HPO4 -2, and PO4 -3. As with most polyprotic acids, the concentration of ions. Do y'all want to have a separate test for each chapter?
Yes.
Okay, I think we will do that. Because this is going to start to be a lot of stuff. The concentration of ions formed in the first ionization is the greatest. So let's go back and read that again. As with most polyprotic acids, the concentration formed in the first ionization is the greatest. So therefore, there's mainly H2PO4 running around. That was formed in the first ionization. Okay, there are lesser concentrations. Okay, we're done. We're going to get there. There are lesser concentrations of the respective ions from each succeeding ionization. Neutralization reaction.
Is that a word?
A reaction that contains an acid and a base and always produces a salt and water. Example, HCl, you're almost done, plus NaOH.
Can you look it up?
Yep. HCl plus NaOH produces NaCl plus H2O. Acid, base, salt, water. Salt, an ionic compound composed of a cation, last sentence, cation from a base and an anion from an acid. Okay, that's it. Hang on just a second, please.